Hi guys, we are continue solving our task, and the next task would be the following one. So we have to convert BST to greater tree. So what does it mean? So we are given a tree node, and also we have a root of binary search tree. So by binary search tree, we know that all elements on the left is less and on the right is greater. Okay, and we convert it to the greater tree such that every key of the original BST is changed to the original key plus the sum of all keys greater than the original key in BST. As a reminder, a binary search tree is a tree that satisfies this condition here. So left less, right greater, and both the left and right subtrees must also be binary search tree. So let's imagine. So we know that the most right position would be the greatest element in our BST. So we can actually we can imagine all this BST as the following. So if we will do in this BST like vertical traversal, we will see that actually we have an array. And when we go like back to this array, we can actually add all elements to this array. So like 15 plus 6, it will be 21, 26, 30, 33, 35, 36, and 0, it would be also 36. So we can see actually that then we are able actually to update all our elements with this value and then return an BS3. So solution can be the following. So first we traverse vertically our BST. Second, we have then we have an array of elements that we want to insert. And the very important thing, like, do we have only unique or not unique elements, and how many we actually can have them? Yeah, okay, all the values in tree are unique, so this is quite important. So in this case, we are able to add key to this value and yeah, to calculate all this actual values back. All right. Okay. So we are traversing vertically our BST. So after traversal, we have the following. We have an array of values, and we have an array of values. So in this case, these values represent like this, but in reality it can be other. So these values will be key in our map. So then we have our map, and in our map we have, for example, 15, and we can traverse back over this array and make like prefix sum. So for 15 we have 15, then we have 7, and we add like for 7 we now add in 15 to 7 and it becomes 22, right? So now 7 would be 22. Wait, why 15? Ah, yes, so it was 15, yes. Yeah, so for 8 it would be, for example, 8. For 7 it becomes 15. For 6 it becomes other things. And then we do like a DFS with update of values. The main question, can we update? I think, yeah. I think we can update this value of the nodes with this method. Okay, so let's try to do this. So the first question, vertically traverse the tree. So how to do this? So if we will go by DFS, so first we go to left, then we go up, then to right, left, up, then to right, left, up, or like, okay, let's, yeah, so when we go to left, so first we go to left, to this element, and so when we should store, so we should not store at the beginning. When we iterate on the left and then go to the right, so before going to the, so after, I think after left, we should store. So for example, here, we have go to the left, we store left, then we store center one, and go to the right. For this two, we should go to the left first, then we go back, we store it, then go to the right, here go to the left, yeah, and then store 3. And then, yeah, go further, we go to 4, and so on. All right. So we are able to do this with DFS. With BFS, I think it would be quite complex because we need then to, yeah, we need to store every element on the row, but we actually don't need this. So let's call it DFS. And in this DFS, we would have a list of integers. So it would be our keys. And we are sending root and our keys. So let's write our DFS first, but I need to add charger. So let's add charger first and continue. Okay. So our DFS tree node, then list integer keys. Here when node, if node is equal to null, we return. Then we are doing node left, yes. So when we return from node left, we add to our keys node value. Then we are doing GFS node right and keys. All right. Yeah. So in this case, we populate all keys, and now we need to create our map integer over integer map And now we are going backwards by our keys length. So it would be size -1 greater or equal to 0, I minus minus, and here we need our suffix sum, that would be 0, and for each key, so it means we get by I our key, and so and here I increment my suffix sum by key, and by this key I need to put suffix sum. After this, I'm update my root with this map keys and values. So I do DFS update, and DFS update I'm sending this root and also this map. So this DFS update would look like this. So I have my node, and also I have my map. And here, if node val is equal, no, like map get node val, here node val equal to this one, and yeah, and I'm doing actually this DFS update for left and right. Node left map and node right map. Okay, so let's check. $47 keys. Yeah, so when I done it, I have to return this root. Can I read val because parameter 1 is null? Okay, let me check. So we have here, yes. So if node is null, we should return. Yeah, because we're going also to null elements as well. Yeah, so we have accepted. Let's submit. Yeah, we are done, but unfortunately it's quite low voice performance, and we can see that it can be actually done much more faster. So actually we are able just to call it here. All right, here's well. Some DFS, update DFS. Yeah, it's something that we need actually. Let's check editorial, solutions, recursion. Yeah. Yeah, so actually we can go first to the right and then update it with current value with sum, and this sum would be like some global variable, and then go to the left. Yeah, it sounds reasonable. Sounds reasonable, actually. So it's quite complex, I think. So they done actually this one in one go. All right, but we finalize this task and see you next time.